Welcome to our November Ask Me Anything and AI debrief. As a reminder, if you haven't joined us for one of these before, this is a monthly series that I do for the GSV and ASU+GSV community, where we try to find some signal through all the noise and all the headlines around AI, and really just synthesize takeaways that we're seeing on the GSV end as we think about the AI and education space evolving. If you haven't seen already, we do have Q&A here, and we will have a lot of time for Q&A, about 15 to 20 minutes at the end after the presentation. So please do add any questions. If we don't get to them, we'll make sure to try to address them in next month's session. But these happen every single month, usually on the last Wednesday of every single month. So really excited to dive deep. If you have any questions at all, please email me. I'm at claire@gsv.com. Super simple, claire@gsv.com. And excited to hear about what questions you all have. Again, please add them in the chat if you have any, and they'll get relayed to me. So if we could pull up the agenda. Today I want to talk about a couple big releases. On the education front, not as many education-specific announcements, though I will say today there just was somewhat of breaking news. Anthropic and Coursera are doing a course on AI, and I haven't had time to digest, but that is hot off the press. But wanted to talk a lot about Google's AI and education initiatives. Specifically, they had a big conference recently, but have been also putting a lot of technical research as well as strategic reports around their mission in AI and education. An interesting partnership from Lovable, Imagi, and OpenAI. And then more recently, just as of yesterday, Google dropping Gemini 3. We had GPT 5.1 from OpenAI. So a lot of big model updates this month. And then generally, I want to talk about this shift from large language models to world models, which we'll dive deep into, which is a fundamental architecture and paradigm shift in how we think about training these systems. And then I'll talk about other headlines that aren't necessarily super relevant to education specifically, but do give us some signal about the future of the internet, the future where all of this is heading, specifically around Amazon suing Perplexity, why they would do that. And then a fun one from Google on their initiatives to build AI data centers in space. So diving deep into it, specifically, Google recently released one of the strongest real world studies that we've seen on whether or not AI tutors actually work in the classroom. And the results are pretty interesting. They basically ran a randomized control trial across 5 UK secondary schools using LearnLM that was embedded directly into ED's math tutoring platform. This is EEDI. They've been around for a while. And so they had LearnLM, which is a pedagogically tuned version of Gemini. So a version of Gemini that is supposed to be Socratic. It's been trained on thousands of tutor conversations. It's tuned to be a better tutor. And they tested this across 7 consecutive weeks from May to June of this year. And they tracked learning across 3,600 plus messages. And a couple of interesting findings, I think, from this study was one, that they found that AI was safe and high quality. They had human tutors supervise every AI message that was being sent to students. And out of more than 3,600 plus drafts, about 74% required no edits at all. If they did require edits, they were often relatively tiny, things like deleting an emoji or removing 1 to 2 characters. And so across the entire corpus of all the outputs from AI systems, they found that 0 were harmful messages, and there were about 5 minor factual errors, which is about 0.1%. So when we talk about AI tutors having hallucinations, this is a pretty strong example that when you have a model like LearnLM that is trained to be a good tutor and grounded in education material, you can significantly reduce both on a safety level as well as a quality and hallucination prevalence level. So that was exciting to see. The second big finding was really around actual learning. So what they found was that the AI performed just as well as human tutors in helping students fix mistakes and understand misconceptions. What they found was that both human tutors and a LearnLM hit over 90% success rates in immediate correction compared to only 65% for static hints. So this is when a student gets something wrong, a tutor comes in and helps fix that mistake. Human tutors have 91% success. AI plus human supervision is about 93% success. And then static hints, just getting a hint after getting something wrong, only 65% success. What we do know here is very clearly that AI tutors are dramatically better than simple written hints, which for a lot of systems today, that's what they rely on. So when we think about these AI systems, yes, there's a lot of room for improvement. We are still in the early days. I would not say that any AI tutor is perfect, but there's already proven gains compared to what we have today, right? I don't think it's a one-on-one replacement for human tutors, but this is a pretty significant example that both human and AI tutors are probably better than static written hints that you get right after getting something wrong. The third finding was just around knowledge transfer. And this is kind of knowledge transfer essentially being whether or not students could apply the concept to the next topic. And what they found here was that LearnLM actually outperformed, I'm still on number 2, but LearnLM actually outperformed human tutors when it came to knowledge transfer. So students who were supported by AI were actually 5.5% more likely to answer the next unit's first questions correctly compared to students who only had human tutors, which basically shows or suggests that with AI's teaching approach, especially if you have this consistent use of Socratic questioning, you could actually build a deeper understanding that has that level of knowledge transfer, that has that ability to carry forward into other subjects as well. So that was interesting. It's an interesting thing that they track. I really hadn't thought of that as a benchmark that I was looking at for a lot of these AI tutors, but I'd love to see more research on this space. Number 4 was that they found tutors themselves, the human tutors who were judging these drafts, who were co-teaching alongside AI, reported that they learned from the AI. So they felt that LearnLM sometimes asked better Socratic questions than they would have thought of. A few even said that supervising the AI changed the way that they teach. And across the board, they said that it definitely made their workflows more efficient because they could support more students at once. So interesting idea that AI can actually play a role in this professional development loop of tutors as well, and not just act as this kind of individual entity that is delivering learning to students. And when you pair humans plus tutors, there's actually a powerful unlock. Number 5 was around the value add. And I thought this was really interesting. When you see where humans did significantly change or made changes to the messages, it wasn't really around the actual learning content, but rather around pacing, tone, and empathy. And this is kind of what I've repeatedly emphasized, is that when you talk about these AI systems, they are infinitely knowledgeable. However, what they're not necessarily going to solve for is the very human aspect of learning, right? A human teacher is going to know what's happening at home. A human teacher is going to know visibly whether or not you are happy or sad in the classroom today. A human teacher is going to know which students you pair better with, or how you do in group settings. And so it's all of these things that I think right now where humans truly have the value add. And you can see that even in this example, you see that when humans are making changes to the actual content itself, they're adding this kind of pacing, tone, empathy, this emotional nuance, and more so helping students redirect when they engage. So I think really this idea, challenging this idea that students are literally only deliverers of information, and where they're really where their superpowers are in being human and adding that empathy, that tone that AI clearly is not able to do because they're machines. So it almost actually sets us up for tees us up for a suggestion that maybe the solution is you have AI as the pedagogical engine, and then the humans as this kind of emotional and pacing intelligence, if you will. Other interesting findings were that students liked AI-supported tutoring. They actually rated them higher than static hints. And most people found that interactive tutoring was more was more helpful and enjoyable. They also saw some early signals of scalability and cost reduction. So tutors who had LearnLM as kind of a co-tutoring assistant, they could manage 3.5 concurrent sessions with students in this digital delivery versus if they were just doing it alone, about 2.3. And I don't know how they're calculating this. It was a very lengthy paper. I would highly recommend looking and looking it up. It's in their press release from last week. There's a technical report in there, but the total cost per sessions dropped 13.6% when LearnLM was used. So interesting as we think about the edtech world, as we think about schools, the unit economics of teaching and scaling, one-to-one learning. I think it's interesting to also think about these metrics as well. Ultimately, there are limitations. I think a big one is this was only tested on math learning. So, their math learning, there's often the actual correct answers are unambiguous. There's really, a very binary output. And so I'd be curious to see how this applies to something like social studies, English, where there is a much more subjective judgment. And right now, this is only used in a short 7-week window. So we don't really know what this means for long-term outcomes, broader cumulative effects. And the other thing to point out is there probably was some level of crossover contamination, as they said. Tutors learn from AI, and then, people who have learned from the pure human sessions may have benefited from them. So it's hard to extract what is a pure AI-driven learning versus pure human-driven learning. And then the other final thing is just that everybody who participated in this was already a high-quality tutor trained on misconceptions. So perhaps when introduced in settings where there aren't high-quality human tutors who have as much experience, AI could actually maybe even have a more significant improvement. But again, that needs to be studied. So exciting first study here. I think, we need more of these. And I think it sets us up to better understand what kind of things we need to track. Broadly, they also released this alongside with their larger AI education roadmap, which talks a lot about how they're thinking about the space and where they see opportunity. Pretty naturally, they also recognize that there is a massive opportunity to bring learning science to every learner, true personalization at scale. So this idea that you can build a low-cost tutor and then make anything learnable. It's interesting because Google search itself is a learning workflow. So I do feel like Google has done a really good job of bringing multimodal content and bringing context from real world learning environments into the broader education experience. I do think compared to other chatbots, they've done a better job of that. So it feels like this feels aligned with what they've done in action. The other two big opportunities are removing access barriers and then AI teaching Copilot. So I guess if you are an entrepreneur in this space, this gives you a little bit of direction around where they are focusing their efforts. But Google is a group that is constantly iterating. I think that's one of the things I admire about them is they're embedding education into everything from Google search to help you with exam prep and guided learning. They have now AI that you can ask clarifying questions mid-video. Notebook LM has obviously been a hit. They've been tinkering around with Learn Your Way and Learn About. There's Google Classroom and Gemini for Education, where they're building in teacher tooling, teacher AI tooling, like for planning, assessments, insights. So those are probably the spaces that they're playing in. Ultimately, there are still a bunch of major challenges that they lay out. These are pretty standard, just around accuracy, hallucination, safety. I'm glad they acknowledge the questions around critical thinking and metacognitive laziness. And then I think food for thought around cheating and assessment obsolescence. They actually say they propose moving towards AI-resistant assessments like debates, oral exams, portfolio, in-class reasoning. So how do you actually build the tools for this new era of evaluation? And it'll be interesting to see. I think there are a lot of startups tackling this space, but I'm curious to see what Google's take is on this. And then they also mentioned the equal access problem, where I think as with any edtech tool, even AI or not, you do have the 5% problem. We saw this with high dosage tutoring as well. The students who benefit the most may already be the highly motivated ones. So questions around how you actually distribute all this powerful AI learning to students. So enough of Google and education, but OpenAI, Lovable, and Imagi actually announced a new partnership, and I thought it would be worth amplifying to you all because they're basically running a broader initiative to bring AI tools to younger audiences and developers. So if you're not familiar, Lovable is a platform that allows you to vibe code. You can use natural language to develop very simple web or app prototypes. And then it allows non-technical users to turn their ideas into functional demos without any sort of coding. I am actually a big Lovable user. I've built a lot of different things internally for the team. But in this initiative, they're offering free Lovable credits as well as OpenAI credits for educators because they want to allow younger students in general to be empowered by this ability to create with very little barrier. And Imagi is an ed tech company from Sweden that is focused on coding to teens. So exciting partnership. I think there's some sort of application or you can learn more about these credits if you are a K-12 educator. But it's awesome to see that, some of the biggest companies in the space are recognizing how important it is to start bringing some of their solutions and creating access to vibe coding at the early stages. For a big drop from this week, we had Gemini 3, which is its most intelligent and most consumer-ready model yet. Gemini 3 Pro is basically Google's strongest swing at OpenAI. By calling it Gemini 3, they're saying it's its most intelligent, most factually accurate, and least sycophantic model to date. And it also comes right after a relatively rocky GPT-5 launch with mixed reviews. Google is explicitly positioning theirs as more reliable and a more grounded alternative. Gemini 3 Pro will be available for everyone on day one, not behind a developer-only gate, and it'll also be rolled out to search AI mode. The big actual, day-to-day changes this means that there's less prompting. They claim that users will need fewer prompts to get high-quality answers. It's apparently better at interpreting intent. It's able to handle deeper nuance. It has less cliche and flattery. And it's specifically marketed as less sycophantic than ChatGPT, which is kind of a jab at OpenAI's sycophancy issues earlier this year. Gemini 3 is also natively multimodal, so they're able to process text, images, audio simultaneously, not as separate modalities. So, for example, you could turn photos of recipes into a cookbook, or you could input a video lecture and turn it into flashcards, or you can vibe code interactive simulations based off of physics problems. So it really is very powerful in that all of those modalities are consolidated into one model. They also have these generative interfaces. So they want to break out of the traditional wall of text issue, which we know that all these chatbots are leaning towards, just delivering you these blocks and blocks and paragraphs of text. Instead, they're experimenting with more dynamic and more custom answers. So you can actually have magazine style layouts. You can have images, charts, simulations, basically even a web page UI that Gemini can create on the fly. So it's pretty cool that we're actually experimenting with or going beyond just the chatbot into really multimodal, both input and multimodal output. And they also have a big push on agents. So Gemini 3 powers a new agent, which is still largely experimental, but it's supposed to be able to organize your emails, research and book travel, plan multi-step tasks, and it can actually also have long horizon agentic planning, which means that it can actually do multiple steps across many days. So yeah, it's exciting. I think, Google has, I would say in the earlier half of the AI race was kind of given a hard time because they weren't outputting AI models as quickly, but it's pretty clear now that you can see the power of Google being able to potentially leapfrog OpenAI and consumer AI. because it has so much surface area of product, they're deeply multimodal. They've been multimodal from day one. They have assets like YouTube. Every image search is indexed. So deep multimodality, interactive interfaces. That's why things like Notebook LM, I would say Google has nailed more multimodal experiences. And now they're expanding into agentic behavior as well. So all in all, very exciting. In terms of the next big model drop from this week, we also had GPT 5.1. And this one is less of a big update. Clearly, it's a 0.1. So you can really tell with a lot of these AI model updates how important they are based on how much of a difference they are from the previous numbers. So, the jump from 4.5 to 5 was relatively big, especially if they have just the number alone. Those are typically flagship models. So GPT 5.1, less of a big splash. It's less a new flagship model, but rather colloquially it's being, or casually people are saying that it really is an update to make ChatGPT less annoying to talk to. So their new model is allegedly warmer and more conversational, which in practice basically means that it follows your instructions instead of giving you a 5-paragraph essay when you really only want an answer that's like 6 words long. It's also apparently better at math, coding, deciding when it needs to think hard versus when it should just answer quickly. And it also has new personality settings. So you can make ChatGPT quirky, candid, professional, or you can even make it cynical. Generally, it's slower than GPT-5, but more comprehensive, at least in my testing. And I've also found personally that the extra thinking time isn't necessarily always worth it, but it is helpful to have. And it is good at asking clarifying questions. So I would say when you're doing a more complex task, it's good to introduce when you want that extra thinking time, when you want those clarifying questions. But I wouldn't say it's a massive step change from GPT-5. And then a broader shift around world models in general. This is kind of a complete paradigm shift in how we think about training AI models. But I want to start with a story that was pretty big news last week about Yann LeCun from Meta leaving. He's Meta's chief AI scientist, a Turing Award winner. He's one of the 3 godfathers of deep learning, and he's reportedly leaving to launch his own startup. For some background, he was brought in 2013 to lead FAIR, which is Meta's fundamental AI research lab. And he's basically been the company's scientific backbone for more than a decade. And his work was much more research oriented, much more focused on actually understanding intelligence and not just productizing AI or building chatbots. This is also coming at a time when for the entire summer, there was a lot of noise over Zuckerberg creating a division called Superintelligence Labs. He had acquired Scale AI's founder, Alexander Wang, to run it. And then after that whole reshuffle, apparently, Meta's top scientist, Yann LeCun, was reporting to Wang. So amidst all of that, it's been a pretty turbulent time for Meta. And then the story that you can say is that Yann was unhappy with how Meta was doing things. But the bigger, I think, ideological tension is actually in what Yann believes is the future of AI development. He's been a pretty long-term vocal skeptic of LLM-centric approaches, and that's what Meta is now betting their company on. He's repeatedly said that LLMs are useful, but they'll never truly plan or reason like humans. And his research is really focused on something called world models. We've heard about these before. I've covered them previously. Google has made big improvements in the space with Genie 3. There's a company from Fei Li called World Models, which we'll go in, or that is building world models that we'll go into. But his research is really focused on building world systems that can learn from video and spatial data and understand physical reality rather than systems that are just predicting the next word. So it's kind of like an AI that is learning by watching how the world works. And he has this approach, which is a new architecture. So not the transformer architecture, but this is a joint embedding predictive architecture, which basically means that they're letting AI systems build internal simulations of the world. I think a good analogy here is like someone understanding how ingredients interact and having that fundamental understanding of every single ingredient versus just memorizing a recipe. And that would be like an LLM that's just memorized thousands and thousands of recipes. It's seen thousands of recipes and it can therefore reproduce recipes. But I think another example is you might say, oh, but video models actually understand world. But one thing to call out there is that video models are essentially visual versions of autocomplete LLMs, right? So I always use the example of a basketball bouncing. The reason that all these video models, because they're diffusion based, they're basically taking one pixel and filling the rest of them out accordingly. Because of that, they don't actually understand physics. They're just able to output. Basketballs bouncing because they've seen thousands and thousands of videos and they've been trained on it. They're able to recall and rebuild that image or that sequence, but it doesn't actually have a fundamental understanding of physics, of how motion works. So that's kind of a good example of why you need these world models that actually understand physics and reality. At the same time, you're also seeing a lot of momentum around this same idea of building systems that can predict the state of the world rather than just predicting the next word. So Feifei Lise in particular just launched Marble, which is the first commercial world model. If you haven't heard of Feifei, she's kind of the godmother of AI. So it's I think a pretty interesting signal that, you have one godfather of AI and another godmother of AI, both moving towards world models because they recognize that this is all very important for robotics, autonomous agents, AGI-like reasoning. So her company raised $230 million immediately off of exiting stealth. And what they're doing is they're also creating these 3D persistent worlds. So they're not just things that are like morphing environments. These are actually worlds that you can explore. And they are also actually VFX and VR and gaming compatible. So the exciting early use cases are naturally that you would be able to generate environments and backgrounds for gaming, for VFX. You can have perfect camera control in these environments. In VR, we know that historically the issue has been lack of content or just the friction and how much effort it takes to build good content. Now you can instantly generate that. That's very, it makes a ton of sense to target those industries. But I think what's even more exciting is actually this idea that you can now create these large scale simulated training environments for robotics, for agents. Basically, we don't have a real world environment for agents to run around and learn how the world works. And in order to do that, we have to build world models. So pretty exciting directionally, probably not going to move as downstream into education unless you're, in VR or gaming or immersive learning. This is probably big. We'll see that move towards the space and in the application layer as well, in the same way that we saw image generation, video generation become much more commonplace. I think we'll see that with world models. But in terms of changing edtech startups, it's not necessarily, a big thing, but I do think it's worth thinking about because it really, so much of the AI world today is built on this transformer architecture. And there's a world where that's actually not how we continue getting capability gains. And it's not how we continue progressing in the AI world. And then, oh yes, I am coming up on time here, but if you have any questions, please include them in the chat. We will get to them in a bit. But I did want to talk about Amazon suing Perplexity as well. And this isn't just another legal battle. Of course, there are many in the AI space. It's not necessarily even over content, but rather actually who gets to control usage of the internet. So companies like Perplexity, OpenAI, Google have very naturally built this new category of agentic browsers. We've covered them, I think, last month and the month before. Perplexity has Comet, OpenAI has Atlas that they just dropped. Google is AI-ifying Chrome. These are basically browsers that can do things for you. So you just give it a task and it runs free on the internet. So in that world, for a human, the AI agent is the actual interface, not me going to apps or other websites. And so Amazon's lawsuit accuses Perplexity of essentially trespassing. They're covertly accessing customer accounts. They're disguising agentic activity as real browsing. They're putting customer data at risk. But most importantly, they say they're degrading Amazon's shopping experience. And Perplexity's response was basically that Amazon was bullying smaller competitors and blocking user choice. They basically said that Amazon is only suing them because they're scared of what happens when AI agents shop for you. And that Amazon shouldn't be able to police whether or not a click comes from a person or an AI. And the big reason they do care about this so much is because Amazon has a $45 billion plus ad industry. And they make a lot of money from sponsored placements when you're scrolling through Amazon. So when I, as a human, am shopping, I see ads. I'm influenced by these sponsored listings. However, if you have a bot, they are less likely to get nudged visually by these ads, and they don't necessarily get influenced by sponsored listings. So you can see how this breaks the entire covenant of like the traditional ads business. And this is the first of many AI shopper wars lawsuits. I expect many more to come. I think the way that we've traditionally thought about the internet economy will face a massive platform shift, because for the longest time, human eyeballs was a currency. The more human eyeballs you got onto Google's 10 blue links or onto Amazon Marketplace, you can monetize off of that. Now that you have agents doing the things for you, buying things for you, making decisions of what you see, that fundamentally changes the math. So exciting to watch. And then finally, just a really cool sci-fi one is just Google wanting to train AI data centers in space. As we know right now, one of the biggest challenges in AI isn't even data. It's not even GPUs. It's energy itself. And these data centers today consume about 2% of global electricity. But this is, we expect with all this AI growth, that number will only grow. The problem is that Earth has physical limits. So the big question here is, why don't we move AI data training into a place where energy is unlimited? And so they are thinking of building or they're planning to build space-based solar power. And solar panels are actually 8 times more productive on Earth or in orbit than on Earth, which means that there's no energy loss. You can have 24/7 power. There's near constant sunlight, no weather interruptions. And through that, you can basically use that energy to directly run compute, which is really interesting. They would use TPUs, which are Google's chips that power Gemini and other AI models, and have them sit in these floating data centers in space. And they would just orbit around Earth. So it's pretty interesting. They also, I won't go too deeply into it, but they'll have really, advanced technology like laser-based optical links. So instead of using fiber optic cables, they beam data between each other. So there's a world where all this data center build-outs actually get shifted up into space. But obviously there are things that they need to solve for, like radiation as an engineering hurdle, because radiation fries electronics, formation control. We've already heard a lot of scary situations where there's a ton of space debris up there. So this is just adding to that issue. And then just cost, which we know is moving and lowering. So historically, launching anything to orbit is about 10,000 per kilogram. But now that's being brought down roughly to 3,600 per kilogram, but still not cheap. But interesting to just think about, I think people always think about AI as this kind of final frontier, but just recognizing that there is so much out there that is still, as you think about the frontier and things and the spaces that we can build, no pun intended, there's just so much out there. And these companies are always thinking about bringing AI to space. How does AI not only impact today's issues around healthcare, education, research and science, but also applying that to longevity, applying that to space. I think there's just largely so many ways that AI can be embedded into all of these, and just generally an exciting time that we live in. Cool. We have about 10 minutes for questions. Is there a link to this Learn LM study from Google? Yes, there is. I don't have the exact, actually, I guess I could pull the exact title, but it's Google in partnership with ED, which is a math platform based in the UK. Sorry, Google DeepMind in partnership. I think if you look it up in their most recent Google release, if you just command F technical report, you can click into it and find specifically the Learn LM study. And this is built off of original Learn LM work where 2 years ago you could see how they developed Learn LM. Question 2, is Google planning to test the ability to reproduce by repeating the study in other countries? Educational research and learning outcomes are very context specific, so reproducibility is critical to ensure the results from the study are relevant. I hope they do. I think that's kind of one of the things they called out was around equality and access here, or equity and access here, where obviously a lot of these AI systems today are pretty much only tested in Western wealthy nations. We do not know if we will see similar results in other contexts and other countries. I hope that they have desires to go test this at scale in other countries as well. We will see. I'm not sure I have visibility into any of these studies, but if you'd like to reach out, they do have the names of all the people who worked on the report and drove the research for the Google and the Gemini and ED, sorry, not Gemini, DeepMind and ED partnership. So I would probably reach out to those folks. And if you are someone that might be helpful for them to actually run some of these studies in other countries, I would definitely reach out. I think there definitely needs to be more educational research that needs to be done in this space. Are there efforts to expand the study to more content-rich areas like physics, chemistry, or biology? I think similar question. I think it's important. I think they recognize, they wouldn't list out in their limitations that this is really only applicable to math. But I hope that there will be more studies similar to this where we can actually see the effects of AI tutors. I do think what gives me some hope is that a lot of people make claims around AI tutors based off of delivery of text. And this is kind of a first example that it's able to help in I would say, a learning environment or subject that usually requires some physical inputs and outputs. So I hope that maybe in physics, chemistry, or biology, you're able to see potentially similar results. But again, we will not know until they do the actual studies. Can these world models like Marble disrupt the VR edtech space like Dreamscape Learning? Really good question. So they are disruptive, but not necessarily in eating the companies that like VR edtech companies. So I think when you think about this, these world models are basically the actual, and they're building the infrastructure for it. So I think of, for example, Sora or VO3, these video models, they are tools that allow you to output video. However, you still need someone to do the storytelling around it, right? Like I think a student is not going to go directly into VO3 and prompt their way into an educational video about Roman history because they don't know what to start with. They don't have that narrative storytelling. They don't have pedagogy around what is, a good lesson in this topic, right? And so that's kind of where the taste and curation layer sits. I still think that will exist. I don't think world model, honestly, or these world like something like Marble or any of these VR output plays are going to go as far as building deep verticals. I don't think there is so much surface area for them to target, like Hollywood, that building specifically education simulations is probably not something that, like the bigger play here is to actually build the platform, right? And then all these people who have curation and taste use that platform to build individual education experiences. So I think, for example, at Dreamscape Learn, they have pedagogy, they have research on how VR impacts actual learning, being able to apply that and using the tooling. So there's a reason why Hollywood studios still are doing largely the narration and the storytelling and the taste part, even though they might no longer, it might be a one-to-one replacement for a VFX person or someone who is in content. It is not a replacement for the actual studio itself, if that makes sense. So that's kind of how I'm thinking about it. But again, TBD has how it all evolves. Could world models be used as digital twins for learning something that exists in the physical world, but the learner experiences the learning opportunity in an equivalent digital world? They definitely could be digital twins for learning something that exists in the physical world. So if you prompt it, you can create versions of, I could be plopped down into a New York City street. I could be in a garden in Kyoto. What they don't necessarily have, and I would double check this I haven't tested it or looked into it for world models, but they don't have like true digital twins. I don't think many systems have like a maps-based system. So I could not plop into a specific, I could not plop into Canal Street or Broadway in New York and have physically accurate representations, because it's not embedding literal street by street view. It is embedding a knowledge of the world. So that's kind of where I would say there are limitations in true digital twins. And then you mentioned the learner experiences, but the learner experiences the learning opportunity in an equivalent digital world. I'm not sure what that entails, but I do think there is a lot of opportunity in using these world models. I can also see, I think, also frictions with this space, right? Like I think historically we've seen a lot of pushback against VR because people don't want to spend why spend hours in a VR headset when you could be in a physical classroom? So I do think just in action that's kind of still where I have questions. As much as we can do it, what will people actually flock to? What will they spend time on? Where is their willingness to pay? What type of market penetration do you predict with the AI browser wars starting to take shape? Or will that just be to increase monetization via GEO and SEO? I think people are starting to use, I wouldn't say like your average, I mean, again, this is all anecdotal off of the people I'm speaking with in the tech world and the startup world and the education world. I wouldn't say AI browsers are particularly common today. I think, especially with something like Atlas, it was very much so a really fun, novel experience. Perplexity common as well, but these systems are still very prone to things like prompt injection attacks, where there was a study done by I think it's called Brave browser, where just by having a little bit of text embedded in a Reddit thread, it actually allowed them to trigger a password recovery flow for your email. So there were questions like, do you trust these AI agents to be operating in your bank account systems, in your sensitive Gmail accounts? Like, I do think that's kind of where I still have questions. It is exciting, and directionally, I think that's where the world will head. In reality today, I don't think there is deep penetration of these. And if anything, I think Google Chrome is very well positioned here because they have so much data across Drive, across shopping, across Google Flights, all the workplaces and spaces that you work in, they have distribution and access to, and that's where their advantage is. So if I were to bet on a horse in the browser space, I would say I wouldn't say they would win, but I would say they're certainly very well equipped compared to others who have to build a browser and kind of break their way into this space. Cool. We are now at time, but I hope this was helpful. I know we had a couple more questions, but I will plan to tackle them for next month's Ask Me Anything. And thank you so much for taking the time to listen to all of this. It's always a pleasure. I love hearing what you all are thinking about. I hope this was helpful. And as always, if you have any questions, let me know. My email is just claire@gsv.com, and I will see you all next month.